Chapter 2 is graphing linear equations. So section 2.1 is where we're going to start, and we are going to start graphing linear equations with a table. We are learning to understand that lines represent solutions of linear equations, and we are learning to graph linear equations. So here's some notes from the textbook that I wanted to highlight. A linear equation is an equation whose graph is a line. The points on the line are solutions to that equation. If you think about a line for a second, a line goes on forever, infinite. So every dot that's on that line is a solution. So we're going to have infinite solutions or points on a line, but we don't need infinite, we just need a few. You can use the graph to show the solutions of a linear equation. The graph below is for the equation y equals x plus 1. Here is the graph, and you can see all of these points or coordinates, right? A coordinate is an x and a y value, are solutions to that equation. And we can find those solutions by creating a table. So let's start with the first example. I would like you to graph y equals negative 2x plus 1. So you're going to pick any values of x that you would like. I always suggest starting with 0 because it's easy to work with 0. And you kind of want to plot closest to the origin. You could pick any numbers you want. You could pick 10, negative 8, negative 4, but remember you have to plot it on our graph paper, so you don't necessarily want to go up to 10. I'm going to pick 0. Let's also pick positive 1, and if you do positive, definitely also do a negative number. So what I'm going to do is take this equation, and I'm going to substitute in my x values. Negative 2 times 0 plus 1. That will get us what y equals. So negative 2 times 0 is 0, plus 1 is 1. So our first solution to this equation is 0, 1. That means x is 0 and y equals 1 satisfies this equation. And we're going to plot that point. Do the same thing for your next values. Negative 2 times 1 plus 1. Negative 2 times negative 1 plus 1. Just substituting them in. So negative 2 times 1 is negative 2 plus 1 is negative 1. So my next solution is 1, negative 1. Let's go over here and plot 1, negative 1. And then the last one, negative 2 times negative 1 is positive 2, plus 1 is 3. Negative 1, 3. And let's plot that point. Negative 1, 1, 2, 3. Now, all you have to do is connect the dots. You connect all the way to the end of the graph paper. You put arrows at the end of the line, and then you label your line with the equation, the original equation, y equals negative 2x plus 1. And that's it. That's all we're done doing. Let's try the next one. Y equals negative 1/2 x plus 2. So sometimes we see a fraction and we tend to freak out, but it's okay because we're going to talk about slope in the next lesson, and slope is always expressed as a fraction. So it's actually easier to work with this equation because it has a fraction. But we'll get to that in the next lesson. You're going to pick your table of values. You're going to write the equation in the middle box. Okay. And I definitely want to pick 0. Now in this case, do I also want to pick 1? Well, you could put 1 here and substitute that in, but I want to pick a number that's going to help me eliminate that fraction. So instead of 1, let's pick 2. If I pick positive 2, I'm also going to pick negative 2. Okay, and let's talk about why did I pick 2? Well, negative 1/2 times 2. Well, negative 1/2 times 2 is negative 1. Plus 2 is 1. Because I multiplied that fraction by the denominator, I have eliminated my fraction. I don't have to graph a fraction. Yay! So that point is 2, 1. Okay, let's go back to the 0. Negative 1/2 times 0 is obviously 0, plus 2 is 2. So my solution here is 0, 2. So let's plot our solution so far. 0, comma 2, 2, comma 1, and then the last one. Okay, again, I picked negative 2 because I wanted to eliminate that fraction. Negative 1 half times negative 2. Well, a negative times a negative is a positive. Half of 2 is 1. Plus 2 is 3. So my last solution is negative 2, comma 3. Negative 2, 1, 2, 3 is here. I'm going to then use a ruler or any straight edge you have available. Connect the dots, put arrows on the end, and label the line with your original equation. So I want you to pay attention to here, why did I pick 2 and negative 2? To eliminate that fraction. Ideally, if you always pick the denominator, you will eliminate the fraction. Last one, the graph y or x equals negative 4. If you notice in this equation, what's different? There is no y variable. Okay? Look at this equation. You're also going to have to graph this. What's different? There is no x variable. So these are a little bit different. Okay? These lines will look a little bit different. So in this equation, x equals negative 4, well, it's telling me what x is. It has to be negative 4. And so what can y be? Well, they didn't specify, so let's pick 0, let's pick 1, and let's pick 2. Why not? And let's plot these ordered pairs. Negative 4, 1, and negative 4, 2. Let's see what happens. Negative 4, 0, negative 4, 1, negative 4, 2. When you have an equation that's just x equals a number with no y, you will get a vertical line. So your table is actually much easier. You don't even need this middle column. The same thing goes for this little example I squeezed in down here. Y equals 2. Well, they didn't tell me what x is. There's no x in my equation. I just know that y has to be 2. So pick anything you want. 0, 1, 2. Watch what happens. Let's plot these points. 0, 2. 1, 2. And 2, 2. Oh, what kind of a line is this? This is a horizontal line. When you have no x in your equation, just a y equals a number, you will get a horizontal line. Now I would like you to try some